You awake, Wendy?
Mhm.
Good. All right, so we're going to find inverse of functions, graph and recognize inverses of relations and functions. Okay, inverse relation, inverse function. Relation is a set of ordered pairs, remember? A function is a relation where every x has one and only one y. Right? What's domain? Yeah, a lot of times. But what does it represent, domain? The x values. Range is the y value. Okay? Stuff we already know. Okay? So, we've talked about inverses with numbers. Right? The additive inverse of 3 is -3. This is basically the opposite, right? The multiplicative inverse of 5 is 1/5. We call it the reciprocal. All stuff we've talked about earlier this year. Okay? Now we're going to do inverse of relations and functions. You can also find and apply inverses to relations and functions. To graph the inverse relation, you can reflect each point across the y equals x line. Reflect just means like a mirror reflection, right? Like if I fold it, they match up, right? Remember our parabolas? We had an axis of symmetry, right? Well, this y equals x line. Y equals x is when x is 1, y is what? They're equal. 1. X is 2, y is 2. Can't find it, huh? No. X is 3, y is 3. Okay? Okay, so this is equivalent to just switching the x and y values in each ordered pair of the relation. Okay? And again, we already talked about a relation. A set of ordered pairs, a function is a relation which each x value has one and only one y value, right? All right, so here's a relation. 0, 2, 1, 5, 5, 6, 8, 9. Okay, so there's the graph of it. See it? A little bit off, but that's what it looks like if you plot those points. If I switch the x and y's, I make the x2 and the y0, I'll get good. You didn't have to, not quite all the way finished though, is it? A bonus?
Yeah, we're going to dig through a garbage can.
I didn't go for the whole class.
And you still came up empty, huh?
Not only did you dig through the garbage, you didn't even find what we were looking for.
All right, so 2 zeros here. And 5, 1 is there. And 6, 5. 1, 2, 3, 4, 5 is there. And 9, 8 is there. So it's a reflection about the y equals x line, which is that one. 1, 1, 2, 2, 3, 3, 4, 4, and so on. So if I fold on that green line, they'd go right on top of each other, wouldn't they? That's what happens with inverses. Okay, they have it on this next page a little nicer than I do. Okay? So the domain values of the blue one was 0 to 8. The range of the red one is the same. You know, they switched, right? Domain and range switch. The range was the y's, you know, for the blue one was 2 to 9. The domain of the red one is 2 to 9. So that's all you're doing is switching them. Okay? So again, we would just switch them. You got a relation. All they're doing is making all the y's 0, 1, 2, 3, 5. Turn them into x's, and all the x's 1, 3, 4, 5, 6 become the y's 1, 3, 4, 5, 6. So far, so good. That's how you inverse relations. Switch domain and range. Okay, Nicole?
Okay.
Okay. All right, and then we could have graphed it. I didn't spend the time graphing. You guys believe me when they'll do that, right? I wouldn't lie to you, will I, Kennedy? No. Not about math, about other stuff, but not math. All right, so when the relation is also a function, you can write the inverse of the function. This is function notation, f of x. F to the negative 1 power means f inverse of x, okay? So functions that undo each other are inverse functions. So here's my function, f of x is x plus 6. So if I put 3 in, 3 plus 6 is 9, right? F inverse of x is x minus 6. So I put 9 in for x. What's 9 minus 6? 3. So they switch each other, right? So they do each other. Simple. Okay. Easy. No problem. All right. So f of x is x minus 1/2. So f inverse would be x plus 1/2. Doing the opposite, right? Make sense? Then they checked it with 1. All right. So then you put a half in, and you get 1. So you put 1 in, you get a half. When you put a half in, you get 1. So they undid each other, right? So they're inverses. All right, what would I have to do to, what's the inverse operation? So I got f of x as x divided by 3. So what's the f inverse? 3 times it, right? Do they undo each other? I guess I put a 9 in there. What's 9 divided by 3? 3. If I get 3. What if I put 3 in there? What's 3 times 3? 9. It worked, right? All right, they did 1. You can also find inverse by writing the original function with x and y switched and then solving for y. That's how we will remember how to do this, Grant. We're going to switch them. Like a switch hitter. You a switch hitter? Oh, man. You're way up here on my baseball list, now you're right on. What about Cade? Can he switch hit?
Kind of.
Can you even hit? Kind of?
Yeah.
Okay. All right, so here's, if I graph that, you guys know how to graph it, right? What's the slope? Negative 1/2. What's the y-intercept? Negative 5, right? We could go down to negative 5, go down 1, right 2, right? It says graph it, then write the inverse of graph. I'm not so worried about the graph part. I just want you to be able to find the inverse part, okay? So, remember, we can, usually we don't like f of x. We like to put what there? We like to put y here, don't we? Isn't that what we like to do? That's what we like better, right? Okay. Again, graph part, don't sweat it. Now, to find its inverse, what are we going to do with these two letters? We're just going to switch them. So we're going to write x equals negative 1/2 y minus 5. And then we're going to solve for y. So what's the first step to solve for y? What's the first step going to be if I want to get that y alone? Move the 5 over. How do I move it? We add it, right? So that's what they did. Now they lost the 1/2 for some reason. Yeah, but there's a negative 1/2 there. It's right in there. It just kind of got pushed in there somehow. Okay, now how do I get rid of the negative 1/2? No. Divide by negative 1/2, but we don't like dividing by fractions. We like multiplying by the reciprocal. So we're going to multiply both sides by negative 2. Okay? You follow me? And then we could distribute negative 2x minus 10. Again, instead of leaving it y, if you want, you could write it like this to show that it's the what? What's that mean? That means the inverse. Right, Danny? Okay? So what did we do again? We made f of x the what? The y, then we did what? We switched them and solved for y. Okay? There's, if we graph them, then, all right, don't worry about the graph. Go ahead and find that inverse, please, on your own. Don't worry about the graph part, just find the inverse. I know you guys can graph that. 2 is our y-intercept. Go up 2 and over 3. Solve for what? You got it started, right?
I think my brain is not.
Move that.
Over here?
Yeah. Just getting y by itself.
So then,
You're moving that. Yeah, that's multiplication.
No, you didn't. So then you do
Reciprocal.
three.
and
But I multiply this all by three then?
Why don't you do the reciprocal?
then you solve for y. So you do
So,
You're missing one. You got enough there, but not there.
When you figure it, then you solve for
Use reciprocal.
I was actually too way up here. It was just three. No, right? So, and then you write the second one. So, you have to switch and take and solve for y by the inverse of x that you already solved.
Correct.
Oh, that makes sense. Okay, so then.
Following, great. Following.
Square, negative 2/2. So then, negative 2, this is.
What'd you get there, Cole?
Negative 2 minus negative 3 seconds.
You don't need to cut
Is positive 3. You need your value.
Not negative. All right, so how do I start?
Okay.
So x equals 2/3 y, right? Isn't that how I started? Y'all okay with that part? All right, now we gotta solve for y. What do I move first, 2/3 or the 2?
2.
The 2, how do I move it? Subtract. So I got x minus 2. How do we get rid of fractions, move them to the other side? Multiply by the reciprocal, multiply by 3/2. Come on, you guys know this. Rules are what you do to one side, do the other, right? So, it's like that. If you want to distribute, you can, you don't have to. If you leave it like that, that's okay. But if I do distribute, it's 3/2 x minus 3. All right, or we could write what? Or we could write that. 3/2 times -2 is -6/2, which is -3, right, Cade? So where's -3? Right there, right? What's my slope? Up 3 and over 2, right? Oops, up 3 over 2, sorry. Gotta erase that. If you had to graph it, again, am I worried about that? Not really. Because I know you guys know how to graph already, correct? I hope. Where's the y equals x line? That's right there, right? Is it like reflect over that? It's always going to reflect over that line. Okay? What are these called? Inverses, right? Inverse functions. Okay? That's it. If I can find that page, sure. That easy. Easy day.
Wait, that's all?
That's it.